This tutorial will illustrate the calculation of the electronic spectrum of a molecule. First of all, we need a molecule. Let's draw good old benzene. So now we have benzene. We need a method. Let's choose semi-empirical method for speed. We can use ab initio, density functional, but let's use AM1 here. The options that we want are configuration interaction. That's going to give us our excited states and our spectra. But first of all, let's look at the orbitals of the ground state, because so we do a calculation and look at these orbitals. Here are the orbitals of benzene, because when we do the CI, we're going to choose a certain number of occupied orbitals to include in the computation and a certain number of virtual orbitals to include in the calculation. We could include everything, but they're really not needed necessarily, and we're going to be faster the fewer orbitals we include. So we're going to include the highest occupied orbitals and the lowest unoccupied orbitals. So let's take a look here at these. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, say. We don't want to include, we want to include both pair of a degenerate pair. So let's have 10 occupied, and on the virtual side, see, we count these 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's use 9 here just for the heck of it. Okay, so we go back and to the setup for the semi-empirical calculation. We're going to choose singly excited CI, and we're going to have 10 occupied and 9 unoccupied included in the computation. We go ahead and we do a single point calculation with CI turned on, and it's going to compute this, take a couple minutes, 20%, 30%. It's done. We now have electronic spectrum, which was previously grayed, is now enabled. If we look at this, this is the spectrum of benzene. This is the lowest state here, which is a triplet state. These are all the states regardless of their intensities. The bottom, coming up from the bottom, are all the states with their intensities. So the triplet is obviously forbidden. This is the first really allowed transition here. If we click back and forth here, we can take a look at this allowed transition here, which is at 204 wave numbers. It's a doubly degenerate singlet. So because of the degeneracy in benzene, this is a degenerate singlet. And that's the lowest transition, lowest allowed transition in benzene.